In our next session, we'll be joined by 3 senior U.S. Department of Energy officials to learn more about some of the exciting technology demonstration and research efforts that are big priorities for the ASME community. We'll cover some of the work the DOE is doing to help build a safe and clean hydrogen energy economy, their work to support deployment of advanced nuclear reactor designs, and a range of carbon capture and management technologies and research that is underway at the Department of Energy. For our first update, I'm pleased to welcome Dr. Katherine Huff, Assistant Secretary for Nuclear Energy at the Department of Energy's Office of Nuclear Energy. Welcome, Dr. Huff, and thanks you for joining us today. Dr. Huff was just confirmed by the Senate on May 5th, so again, thank you for jumping into our program. But in her current role, but prior to her current role, she led the Office of Nuclear Energy as Principal Deputy Assistant Secretary and served as Senior Advisor to the Office of the Secretary of Energy. She received her PhD in nuclear engineering from the University of Wisconsin-Madison and her undergraduate degree in physics from the University of Chicago. Her research focused on modeling and simulation of advanced nuclear reactors and fuel cycles, both key topics of interest for our audience today. And again, I'd like to remind our audience to use the Q&A button in Zoom to submit your questions throughout our presentations. And we'll keep them coming as we go, and we'll get to as many as we can for our DOE speakers. With that, Dr. Huff, thank you for joining us. Oh, it looks like she's muted. If we could get her unmuted.
Thank you very much. I'm so appreciative. And thank you to ASME for having me, for, also for your work to, be a trusted source of engineering expertise, and your leadership and engagement on these topics is really important, I think, for the world to hear that trusted source, recognize the importance of these kind of national concerns that we have about energy. And I think you're really highlighting some interesting stuff. I listened to some of the last session, and I think it's really aligned with where we're going to think hard about these kind of topics. So, actually, as an aside, I was raised by 2 mechanical engineers. And so I grew up in a place in sort of southeast central Texas. And we didn't get a lot of magazines, but there were always at least 2 copies of Mechanical Engineering magazine lying around. So I'm sure that had a pretty important effect on my formulation as a human being. Yeah, so, I became a nuclear engineer, which of course I think of as a, sibling to mechanical engineering. And I think we're really aligned. Anyway, fun fact there. So anyway, I think as we talk about priorities, the Biden administration recognizes that carbon-free nuclear energy is going to be absolutely vital to our decarbonization goals, to our energy security. And, at the same time, nuclear supports the kind of economic vitality of communities and creates jobs. And so one of our biggest priorities in the Office of Nuclear Energy right now and into the near future is that we need to maintain the existing nuclear fleet because it produces half of our clean electricity in this country. And it's the single largest source of carbon-free electricity. So, the bipartisan infrastructure law was recently passed, and in it, there was this $6 billion civil nuclear credit program, and its purpose is to keep clean carbon-free nuclear reactors operating in markets where they aren't rewarded historically for that clean, firm generation. And so this civil nuclear credit program seeks to correct that flaw in the market systems where it's missing. And today, right now, owners and operators of nuclear plants that are at economic risk can apply to be certified, and they can bid for credits to keep their facilities running and avoid premature closure. These civil nuclear credits are going to be really instrumental in ensuring that we keep those reactors online, keep folks employed, and ensure that we can continue to keep our single largest source of clean energy running. This is going to preserve thousands of high-paying jobs, and it's really essential to just maintaining our base of clean energy. But the second part of our strategy and our second highest priority in this office is looking ahead to the future of nuclear energy. And it's really aligned with our role as a research and development arm of DOE. The Office of Nuclear Energy recognizes that, there's a lot to be done in the near term, and advanced reactors hold a lot of promise. We're excited that we're on the precipice of commercialization for a very large number of these designs. Some designs truly are ready to be commercialized today. More than 20 US commercial developers have really very serious startups, and they're already pursuing advanced reactor technologies in this country. Secretary Granholm likes to say, deploy, deploy, deploy. And that's exactly what we're doing with some of those companies. And that's through largely the Advanced Reactor Demonstration Program, as well as our Carbon-Free Power Project. ARDP, this Advanced Reactor Demonstration Program, has a goal to develop, license, construct, and deploy 2 advanced reactors by 2028, while simultaneously supporting reduction of technological risk in a larger number of designs, and envisioning a future where the designs that need additional technology readiness development over the course of the next decade and longer also get funding. But those 2 advanced first-of-a-kind demonstrations will be deployed this decade. The first is X Energy's XE100. It's a small modular high temperature gas reactor. It'll be deployed in Washington State. And it's very clever. It uses pebble fuel with tristructural isotopic particles that have some really clever silicon carbide containment at the sort of micrometer scale. And it's cooled by high temperature gas, and it can reach incredible temperatures. And that very high quality heat is really important for decarbonizing some of the really hardest to decarbonize areas. It can also contribute to things like hydrogen production, where a combination of electricity and heat can be some of the most efficient production of hydrogen that we have available. There's additionally, so the second of these 2 demos is TerraPower's Natrium reactor, which is it's a sodium cooled fast spectrum reactor. And that's going to be sited at a retiring coal plant in Wyoming. And that is kind of a fantastic narrative as well that I think we really want to see in this office and in DOE more broadly, is to bring fossil communities along with us as we transition to cleaner options while those fossil assets are retiring. And TerraPower's sodium cooled fast reactor is really going to demonstrate that specifically for the kind of one-to-one small modular reactor coal transition. So you take a coal plant and you sort of one-to-one replace that firm capacity with a cleaner alternative while that fossil asset is retiring. So it has the benefit of using a lot of existing infrastructure. It's got the right sort of capacities and sizes. Small modular reactors and coal facilities are typically approximately the same magnitude of capacity. It's got similar power profiles. You use the same cooling water sometimes, though advanced reactors rarely need as much cooling water as their older counterparts. And we can use the same workforce. You need the same engineers and electricians and union boiler makers and steam turbine operators. And so that kind of activity is it's critical to ensure that we bring communities along in this transition. Anyway, the bipartisan infrastructure law is going to cover a lot of the funding for those 2 demonstration projects over the course of the next 10 years. And I invite you in 2028 to go out there and take a look at how far we've come in these demos. I hope they'll be connected to the grid by then. We're going to be watching them closely. In addition to that, we're also supporting the Carbon-Free Power Project deployment of the NuScale small modular reactor. This is like a shrunk down version of our pressurized water reactors. And so it borrows from historic technology, but uses a lot of miniaturization capabilities, natural circulation, these kinds of things. And that's going to be deployed out in Idaho. And it is the first small modular reactor to receive design certification from our nuclear regulator. So that really puts it in a place where it can, build out an order book of orders. And there are nations all over this world, in particular this last few months in Eastern Europe, where energy security and firm energy support for their clean energy transitions are really needed. I'll be in Romania next week and Bulgaria talking with nations interested in technologies like these. And NuScale is a really great option because they have the sort of certified stamp of approval from the Nuclear Regulatory Commission, which is the gold standard for regulation in the world. Anyway, so, there's a kind of just general optimism that advanced reactor technologies like these, which represent just a full leap from the technologies we deployed in the 60s and 70s, they hold massive potential for decarbonization, not just in the electric power sector, but for lots of other applications for heating, district heating and otherwise. desalination, clean hydrogen, and a lot more. You know, I know you'll hear from Sunita in a bit, but I have to say, and she knows this very well, nuclear power and hydrogen go really hand in hand. One of the hydrogen hubs will be a nuclear hydrogen related capability. And we already, even before the bipartisan infrastructure law in NE and EERE, we're already collaborating on demonstrations of hydrogen produced from existing nuclear assets. You know, we have a long list of 4 demonstration facilities where at existing nuclear power plants will be demonstrating the production of hydrogen from that clean energy. Some of the, you know, first real, you know, useful scale clean hydrogen in the US. So we're really excited about that. It'll be at Davis-Besse, 9 Mile Point, Prairie Island, and Palo Verde nuclear generating stations. So those are the 4 to watch as we look out towards a future for hydrogen. But then additionally, there will be hydrogen hubs that are a separate program that Sunita will talk about. You know, I'll leave you with a final sort of thought. You know, I think the Biden administration has been very clear that clean energy is a priority. We've set ambitious goals, and they're not going to be met unless we maintain and grow our nuclear power capability. And that's borne out by, you know, energy assessments worldwide. But the other thing that we won't achieve if we don't grow our nuclear energy capacity is energy security. And I think in the last few months, as we've watched what's happening in Ukraine, and we've questioned where we stand in our own supply chains for lots of energy technologies, technologies that can be supported with, you know, resources that we have here in the United States and don't require a lot of movement of fuel and a lot of supply chain links. They're very attractive. Firm energy is very attractive, and it can really help us with our energy security here in the US. And it can also help diversify the supply to our democratic and European allies in particular, you know, for whom this is a real critical survival question. So, you know, I'm really hopeful that our commitment in a broad sense will help with energy security more broadly and democratic security globally. So I'll just leave you with that thought. Those are our priorities right now. You know, we're thinking about a lot of things, but as we think about deployment, those are the things we're thinking about.
I'm now pleased to welcome our next DOE speaker, Dr. Brian Anderson, Director of the Department of Energy's National Energy Technology Laboratory. Welcome, Dr. Anderson, and thank you for joining us. Brian manages the entire National Energy Technology Laboratory complex, including delivery and execution of the laboratory's mission in fossil energy and decarbonization, and other DOE mission areas with industry, universities, national laboratories, the hundreds of partners we have with our national lab institutions. Dr. Anderson holds a BS in chemical engineering from West Virginia University and an MS and PhD in chemical engineering from the Massachusetts Institute of Technology. Brian, with that, I will turn it over to you. Thank you for joining us. Again, audience, I remind you, keep submitting those questions in the Q&A. Thank you, Brian.
Well, Paul, thank you so much, and it's a great pleasure to follow my colleague, Dr. Huff, from the Office of Nuclear Energy. I'm representing both the dual-hatted nature of the One Go laboratory, like NIST earlier today, within the Department of Energy, in that we are the federal laboratory that manages a lot of programs in carbon management, even the programs in vehicles technology. Many of the ASME members are quite familiar with the Vehicle Technology Office, batteries, cybersecurity, energy security, emergency response, the Office of Electricity, and then now with the bipartisan infrastructure law, we're working hand in hand with the Office of Clean Energy Demonstrations, Manufacturing Energy Supply Chains, and the Grid Deployment Office. But we're also a national laboratory. And so today, I'm going to spend the next few minutes really focused on some of the technologies we work on at the laboratory, both in-house and through our extramural partnerships that we fund. And so the way we think about the decarbonization pathway, it is a journey, and it is a path-dependent journey when we get to the end state. We know that the goals are clearly stated by the administration, and lots of industry is following suit, that we are going to decarbonize our economy in the United States by 2050 as a net zero carbon economy. By 2035, 100% clean energy, clean electricity production, reducing that by 50% by 2030. And so what we're trying to do at NETL as part of the Office of Fossil Energy and Carbon Management, in support of all the other program offices that we support that I mentioned, is pave that way to the decarbonized energy future. We've been working at NETL for the last about 30 years in carbon capture and sequestration technologies. Folks might not know that our origins at NETL are 112 years old now. We were, in some instances, the first of our DOE national laboratories. And our challenge 112 years ago was in the mining industry and mine explosions in 1908. Today, our mission is to drive innovation for our collective environmentally sustainable and prosperous energy future, while that pathway requires that we optimize a few variables. It needs to be affordable, abundant, reliable for national security, economic security, and we're managing carbon across the full life cycle, from the wellhead to ensure that we're mitigating and minimizing methane leakage, all the way through the end state to make sure that we're a net zero carbon. And so I've mentioned this a couple of times. We're all driving for the carbon-free power sector by 2035 and net zero economy by 2050. And there's a lot of challenges associated with that path. But those challenges present opportunities for us. And those opportunities for us, and we're looking at the opportunities for economic revitalization, diversifying economies for existing energy communities. NETL and I was asked by the administration to lead an interagency working group on coal, power plant, and energy communities and economic revitalization. We have 12 federal agencies all aligned together in how, as we decarbonize our economy, we're going to spur innovation that helps catalyze economic revitalization. We have $205 billion right now on our interagency clearinghouse, everything from broadband to infrastructure to carbon capture and sequestration. That's what I want to focus the rest of it on. And so what's really rewarding is not only are we working on technologies and innovations, but ones that have the potential to really improve people's lives in meaningful ways. So within the Office of Fossil Energy and Carbon Management, we have a number of RD, D&D priorities. I'm going to give you the top line is how we demonstrate and deploy point source carbon capture. So this would be at emission sources, not just power plants, but also in the industrial sector. And I'll go to some more specifics there. Then carbon dioxide removal and low carbon supply chains for industry. This is the carbon dioxide removal space is everything from an enhanced weatherization and mineralization to direct air capture, to also using biomass in carbon capture, so we can reduce and remove the emissions that are in the carbon sink in the atmosphere, and also, but it's really used to for those hard to decarbonize emissions at the tail end, the last few percent that get really hard to decarbonize. Accelerating carbon neutral hydrogen and the low carbon industrial supply chains are vitally important to get to that 2050 goal, and we have to work on it now. And that's why I give the context as paving the pathway. I've already mentioned methane emissions, and then also a big part for us is how we can ensure that we have supply chains, abundant supply chains for critical minerals, rare earth elements, and so there are some opportunities for us to co-invest in mine reclamation and remediation while extracting rare earth elements and critical minerals that are vital to everything from permanent magnets to electronic circuits and chips. We're doing all this while addressing the energy water nexus using big data and artificial intelligence. And then I've mentioned, again, the pathway, the revitalization of economies, how we can invest in thoughtful transition strategies as we move from a 85% fossil-based economy to a zero emission economy is going to require some thoughtful transition strategies, or else we'll leave communities behind. And so when we get into very specific in the carbon capture program, I mentioned we at the laboratory and in fossil energy and carbon management have been developing the technologies for nearly 30 years. The first and second generation technologies we're targeting by 2025, something on the order of $40 per ton of CO2, and not all emission sources are created equal. There are certainly emission sources that are high high percentage of CO2. Those are come at a lower cost. And other emission sources, even natural gas combined cycle sources that are a much lower percent CO2 that will come at a higher cost. But really targeting the capture cost, very specific, just the capture cost of $40 per ton of CO2 in 2025, $30 per ton using some transformational technologies by 2030. And we are on a extremely accelerated pathway for scaling up the technologies. I say extremely accelerated because of the billions of dollars in the bipartisan infrastructure law that we are deploying now. You can see even within the past couple of weeks, we've released notice of intent on the carbon sequestration FOAs that are forthcoming in the bipartisan infrastructure law. And then beyond the technologies beyond are in the negative emissions technologies, carbon dioxide removal. And there's a lot of work for us to continue driving down the cost, scaling up and moving toward commercialization. And so our approach is to span the entire TRL scale from lab to bench to feed studies and then now demonstration through the BIL. And we have a very integrated program across all of the different technology readiness levels, including additive manufacturing, advanced manufacturing technologies, as well as process modeling, smart manufacturing, that again is both post-combustion, pre-combustion, point source, and distributed carbon removal technologies. And so there are some great examples once we capture the CO2 for carbon utilization using catalytic conversion of fuels and chemicals. We can see there are very difficult to replace fuel stocks that we have in the liquid fuel space, that if we get to a net zero economy, we're going to have CO2 conversion coupled with hydrogen into zero emissions fuels. Then certainly algae and bioproducts and organic materials using CO2 as a working fluid. We have a project called the STEP project in Texas, which is demonstrating using CO2. And then also how we can, through the process of carbon capture, mineralization, and using CO2 to build building materials like the Carbon Built X Prize announcement that was recently awarded. Another area for us is certainly in hydrogen. We're going to hear from Sunita here in a moment. But we know that we're going to produce hydrogen from a number of different feedstocks, including from, I don't want to go through the collars, but there will be carbon-free, carbon emissions-free hydrogen that come from the origin and from fossil fuels. And a couple of our key technology areas we're working on is in natural gas pyrolysis, certainly steam methane reforming with carbon capture, using ammonia as an energy carrier, and then in the end, research that we have going on and using ammonia as that fuel into combustion turbines, and how we can utilize hydrogen as a combustion fuel even more efficiently. And one of the exciting projects is using our rotating detonation engine. It's a pressure gain combustion system that we have here at the laboratory that can run on the minute time scale due to some innovative cooling jackets that we have. So a real opportunity. And then to show that this is not pie in the sky, we have in the United States been demonstrating blue hydrogen from natural gas at the Air Products process in Port Arthur, Texas, capturing CO2. Currently, this project started in 2009, capturing 90% of the CO2 from an SMR, the other SMR, the steam methane reformer. And it has captured over 7 million tons since 2013. And so when we look at the options of producing low carbon hydrogen, we can point to these demonstrations as part of that portfolio, but of course it has to couple back to CO2 capture, CO2 utilization, as well as all of our sequestration.
We now have an update on the administration's Department of Energy-wide hydrogen program efforts from Dr. Sunita Satyapal, Director of the Hydrogen and Fuel Cells Technology Office within the Office of Energy Efficiency and Renewable Energy.
So first of all, thank you for the kind invitation. It is an honor to be able to present today on behalf of the U.S. Department of Energy's Hydrogen and Fuel Cell Technologies Office, where I am the director and also responsible for coordinating across the U.S. Department of Energy's hydrogen and fuel cell programs. So what I'd like to do today is really cover three main messages. And the first one is the sense of urgency and our key goals in terms of the climate crisis. And if you look at US energy consumption, you can see we rely very heavily on fossil fuels. And our goals, the administration priorities, are net zero emissions by 2050, a 50 to 52% reduction by 2030, and a completely carbon-free electric grid by 2035. So meeting our climate goals, energy security, resiliency, all of these are high priorities for the administration. And I'd also like to emphasize the environmental and energy justice priorities, EJ40, where 40% of our federal benefits would impact disadvantaged communities and those who have historically experienced environmental and energy injustice. So hydrogen is one part of a very comprehensive portfolio, and we have a DOE-wide strategic plan, which you can see on our website, and it includes multiple offices, the entire value chain from production all the way through end use, and all of our resources, so offices involved in renewables and nuclear, fossil and waste, plus CCS, and basic science all the way through to deployment activities. We have over 400 projects, over 200 companies and universities, 15 national labs, and the budget ranges from about 100 to 400 million per year, depending on the year. But our priorities are really threefold. First, we have to reduce the cost of clean hydrogen. Second, we need obviously low cost, efficient, and certainly safe hydrogen infrastructure, delivery and storage. And third priority is enabling end use applications at scale. So we also include workforce development, safety codes and standards, and really getting to scale, which is depicted in our H2 at scale initiative, which shows the Swiss Army knife perspective of hydrogen. The fact that you can produce it from diverse resources and you can use it in multiple applications. So it shows the versatility, the fact that you can use it as a fuel or as a feedstock. It gives you more optionality and flexibility. It can be more dispatchable. You can store it, feed it back to the grid. And so again, offers multiple options, but the focus is those hard to decarbonize sectors. So industrial applications. Steel alone accounts for over 7% of global emissions. Heavy duty transport, such as long haul trucks, where there are not too many alternatives. Long duration energy storage. And today in the US, we produce about 10 million metric tons of hydrogen, mostly from natural gas. But we see this potential for over 2, even over 5-fold increase. And to give you an example, if we produced another 10 million metric tons of hydrogen from renewables, that would basically double today's solar or wind. So it's really an enabler to enable a clean grid and significant opportunity for jobs and revenues. And where are we today in the US? We have thousands of fuel cells, so backup power, stationary power, over 50,000 in the niche markets of forklifts. In fact, major companies such as Amazon, Walmart are refueling. In fact, every few seconds, some customer is refueling with hydrogen in a warehouse. So significant market penetration there, over 170 megawatts. This is very rapidly changing. This is just one snapshot of PEM electrolyzers, about 70 buses, 50 retail stations, mostly in California, for over 12,000 cars. And most regions have hydrogen production from natural gas. We have over 1,600 miles of dedicated hydrogen pipeline, 3 geological caverns, including the world's largest in Texas, and really a growing infrastructure ecosystem of hydrogen that we see emerging. But the key is really cost, which brings me to my second message, and that's really cost. So last year at the Climate Summit, President Biden asked our Secretary of Energy, what more can we do to accelerate the development of critical technologies to tackle the climate crisis? And that was the beginning of the Energy Earthshot initiative. So similar to the moonshot from over half a century ago with John F. Kennedy, these are bold, ambitious targets. Hydrogen Shot was the first one launched with a goal of 111, so easily articulated, which stands for $1 for 1 kilogram of clean hydrogen in 1 decade. So today, hydrogen is about $1.50 from natural gas, but over $5 from renewables. So it's an all hands on deck approach. We had a summit with thousands of participants. Our Secretary John Kerry, Bill Gates, industry CEOs, congressional members, experts from around the world to 34 countries. And this is just an example of the feedback that we got from the broad stakeholder community when we asked, what are the greatest barriers? There are significant challenges to enabling hydrogen at scale, widespread competitive hydrogen at scale. You can see the number one challenge was voted as cost, but there are a number of other challenges. So the need for sufficient infrastructure, public awareness and understanding, lack of incentives. So again, multiple challenges, and we will be looking at all the possible pathways. So electrolysis today over $5, multiple contributors. Green is the cost of electricity, blue is the capital cost, gray is the operating maintenance cost. But we're developing strategies on how can we reduce cost to get to $1 and looking at multiple resources. So for instance, waste plus CCS. This too shows, for instance, capital, fuel cost, stepping stone of how do we get to $1 and advanced pathways. So direct photoelectrochemical, biological or hybrid approaches, any approach that can get us to $1 for clean hydrogen per kilogram within a decade. And so we are also looking strategically at where are the resources. So renewables like wind, solar, biomass across the country, nuclear plants, natural gas, coupled with CCS, to look at where could we co-locate production and enable infrastructure getting to scale. Which brings me to a very exciting announcement with the Bipartisan Infrastructure Law, also called the Infrastructure Investment and Jobs Act, which was signed into law by President Biden in November and provides over $60 billion for DOE with $9.5 billion for clean hydrogen. That includes $1 billion for electrolysis, research through demonstration, $500 million for clean hydrogen manufacturing and recycling technologies, and then $8 billion for at least 4 regional clean hydrogen hubs that would include production all the way through end use in close proximity, aligns with Hydrogen Shot with a concrete goal of $2 by 2026, and it includes developing a national hydrogen strategy. And finally, I'd like to end with my third and last message for today is the importance of collaboration and the high priority of diversity, equity, and inclusion in everything that we do. And since there are probably many experts in the audience, I always like to remind ourselves that no matter what you do, no matter how hard you try, no one person can whistle a symphony. It really takes a whole orchestra. So now more than ever, we need all hands on deck, industry, governments, the private sector, investors, the global community to enable clean hydrogen technology. So we have a very wide and diverse number of international partnerships as well as domestic partnerships. There's some shown here. Most recently, H2 Twin Cities, for instance, under the Clean Energy Ministerial, the Glasgow Breakthroughs launched at COP, IPHE, an early career network. If there are any students or postdocs, again, we have over 34 countries completely run by students and early career professionals, facilitating international trade, tremendous resources available. So in summary, we will be accelerating our RD&D to reduce cost, launching our demos and H2 hubs program, co-locating that production through end use, getting to scale, sustainable market liftoff, and then enable concrete, tangible benefits, really enabling that resilient, sustainable, and equitable clean energy economy. So with strong emphasis on the disadvantaged communities, the EJ, tribal communities, those concrete benefits, tangible impact, working with all the stakeholders. So with that, we have tremendous amount of resources available. Please save the date for the week of June 6th. We have our annual merit review with a couple thousand people showcase all of our projects. Increase your H2 IQ webinars. Again, there's limited understanding about hydrogen, H2 tools, a Center for Hydrogen Safety, over 70 global partners. So again, significant resources available. And with that, I'd like to thank you for all of your leadership and support for hydrogen and wish you a good rest of the conference. So we look forward to staying in touch.
Thank you, Dr. Satyapal, for that great update. And thank you to all of our DOE speakers for joining us today. We're very excited to follow the rollout of these programs.